Welcome, everyone. Thank you for joining us today. My name is Beheshteh Abdi, an instructional designer at Rutgers Online Education Services at Rutgers University on behalf of 2025 Rutgers University Learning Conference. I also welcome Dr. Katayoun Mobasher, Professor of Geology from University of North Georgia. We are pleased to present innovative geology education with game-based learning, enhancing engagement, retention, and recruitment in geology education. During the presentation, please engage using the live chat session. You may post any question you have, and we will answer as we go along and as time permits at the end of our presentation. Okay. In this session, we will define game-based learning and its elements and comparing GBL with traditional education methods and explain how it can enhance engagement and learning performance. Also, we will review research findings on its effectiveness in geology education and also discuss practical application and case studies. Let's start with defining game-based learning and understanding why it's ideal for geology education. But before that, I want to just take time to briefly, talk about the types of game-based games in education. There are various types of games used in education, each serving a unique purpose in enhancing learning experiences. Let's explore some of those, the most actually common ones. First, we have traditional games. There are classic non-digital games such as board games and role-playing activities that have been adapted for educational purposes. They encourage strategy thinking, collaboration, and hands-on learning. Then there are gamification, which is another approach often used in education. While it's not a game itself, it involves adding game-like elements such as points, leaderboards, and rewards to non-game contexts to increase motivation and engagement. Next, we have mixed reality games, which integrate augmented reality or virtual reality to create immersive and interactive learning experiences. These games allow learners to explore virtual environment that enhance understanding and engagement. Next type of games are simulation games. These mimic real-world processes and real-world processes and provide a risk-free environment where learners can practice decision-making and develop problem-solving behaviors. They are widely used in fields like medicine, aviation, and engineering. Next, we have serious games. These are purpose-built games designed specifically for education, aiming to teach skills, concepts, or real-world applications in a structured way. They go beyond entertainment and focus on measuring learning outcomes. Another category is sandbox games that we are going to talk about that also in this presentation. These open-ended games allow learners to freely explore, create, and experiment without predefined goals, fostering creativity and self-directed learning. A great example of this is Minecraft. Finally, we have game-based learning, which is a focus of this presentation, or GBL, which involves using commercial or educational games to teach concepts in an interactive and problem-solving manner. This method transforms traditional learning by integrating fun, engagement, and skill development into the process. By leveraging these different types of games, educators can create diverse and effective learning experiences that cater to various learning styles and objectives. Before delving into how GBL transforms geology education, let's first define what it is and how it differs from traditional learning approaches. There is a very important definition of game-based learning by Nebel and et al. 2000, in 2020 to 2016. They mentioned that they define game-based learning as a structured form of gameplay to achieve learning objectives. It incorporates game mechanics, digital simulations, and interactive storytellings into the learning process. Unlike traditional education methods, which often focus on lecture and memorization, GBL allows students to engage with content through active problem solving and exploration. So we have very important, key components of this definition. First, it's a structured form of gameplay designed for achieving learning objectives, ensuring that the learning experience is purposeful and goal-oriented. Also, it incorporates game mechanics like digital simulations and storytelling, making learning more interactive and immersive. Plus, unlike traditional education methods that focus on lecture and memorization, GBL shifts the focus to active participation and hands-on learning. Additionally, through engaging challenges and interactive tasks, students develop problem-solving skills and explore content meaningfully. Ultimately, game-based learning enhances engagement and motivation and transforming the learning process into a more dynamic and enjoyable process and experience. These elements work together to create a more effective and engaging approach to education. Okay. We have some, let's talk about the key game elements in game-based learning. First, challenge, game-based learning is a challenge-based game, and it challenge-based learning and problem solving. It's very important. Effective educational games usually present obstacles that require critical thinking, decision-making, and strategy to progress. This helps learners develop problem-solving skills and resilience while keeping them engaged. Next, we have narrative and storytelling. A well-created story provides context and meaning to learners, making complex concepts easier to understand and more memorable. A compelling narrative helps connect game objectives with real-world applications, increasing learning engagement. Instant feedback also is very important. One of the key elements of the games, and adaptivity is another critical component. Unlike traditional learners where feedback is often delayed, games provide immediate response to a learner's action. This reinforces understanding, correct misconceptions, and allow learners to adjust their strategies in real world. Also, exploration and open-ended discovery is the key to fostering curiosity and deeper learning. Many game-based environments allow learners to explore freely, experiment with different strategies, and discover solutions on their own. This promotes self-directed learning and encourages creativity. Finally, collaboration and multiplayer learning. Many games encourages teamwork and communication, helping learners develop social and cooperative problem-solving skills, whether working in teams or competing in challenges. Learners gain usually valuable experiences in collaboration and shared decision making. By incorporating these elements, game-based learning transforms traditional education into an engaging, interactive, and immersive experience. Now, let's explore how these principles can be applied across different subject matters. But before that, I want to talk about the benefits of integrating game-based learning in classroom. Briefly, you can see that in the table, numerous studies have highlighted the positive impact of incorporating game-based learning in the classroom. One of the most significant benefits of using game-based learning in education is increased student engagement. when learning is interactive and fun. So when learning is interactive, fun, students are more motivated and they mostly participate in and retain information. Another advantage is the improvement of problem solving skills. GBL challenges learners to think critically, adapt strategies, and find solutions in real time. It also enhances collaboration and teamwork, as many game-based activities encourages peer interaction and cooperative learning based on these studies. Also, additionally, GBL foster creativity and deeper understanding by allowing students to explore, experiment, and apply knowledge in a dynamic way. Overall, this studies shows that why game-based learning is an effective and impactful approach in modern education. So I have prepared a slide about from an instructional design perspective what game-based learning makes GBL effective from an instructional design perspective. The first thing is the first and foremost for the game-based learning is to be valuable. Is that it should be aligned. The game should be aligned with learning objectives, and writing a clear learning objectives is very important. Games should not just be engaging; they should also actively reinforce key skills and concepts. One way to achieve this is to by designing games that challenge learners to think critically and solve problems in a way that support their learning goals. Instead of simply playing for entertainment, students engage in a meaningful decision making and exploration that enhances their understanding. Also, beyond aligning with learning objectives, the content with the game must also serve as an effective learning tool and that rather than just a source of entertainment. One way to ensure that is by incorporating a strong narrative. A compelling story provides context that making learning more meaningful and helping students connect new knowledge to real-world application. In addition, exploration-based learning is highly effective by allowing students to interact with the content freely, encourages curiosity, experimentation, and a deeper understanding of their subject matter. The third effective way is designing engaging and collaborative learning activities. Now that we have looked at the content, let's talk about the learning activities themselves. A well-designed game should keep students engaged and encourage collaboration. Interactivity is a key. Instead of passively consuming information, learners should actively participate, making decisions, solve problems, and apply their knowledge in different scenarios. Furthermore, collaboration enhances learning experiences. While when students work together in a game-based environment, they build teamwork, communication, problem-solving skills, and all of which are essential for real-world applications. Plus, assessment and immediate feedback for learning enhancement is really important. Of course, no learning experience is complete without assessment. One of the most valuable aspects of GBL is its ability to seamlessly integrate assessment into the learning process. To ensure progress is tracked effectively, games should include both informative and summative assessment. This allows educators to measure skill development over time while giving learners an opportunity to reflect on their growth. Equally important is immediate feedback. When students receive real-time responses to their actions, they can recognize what they are doing well and where they need improvement. This instant reinforcement helps guide them toward mastery. Finally, accessibility and inclusivity is very important to recognize that game-based learning should be accessible to all learners. A well-designed game considers the diverse needs of students and ensure that everyone has the equal opportunity to succeed. One way to achieve this is through adaptive learning path, which allows games to adjust to different skill levels and provide a more personalized learning experience. Additionally, flexible gameplay ensures that learners with different abilities, learning styles, and backgrounds can engage effectively. By making GBL inclusive, we create an environment where all students can benefit from interactive learning. To sum up, effective game-based learning goes beyond entertainment by carefully designing games with clear learning objectives and aligning with learning content, learning activities and assessment, structured content, interactive and collaboration activities, and embedded assessment and inclusivity. We can create a truly engaging and impactful learning experiences. When doing right, GBL is not just fun. It's a powerful tool for deepening learning and skill development. Now, let's explore some real-world examples in GBL in using GBL in geology education.
Thank you, Beheshteh, and thank you everyone for being with us this morning. I'm going to talk about how GBL can be used in geology education. So we have put together or summarized about 7 reasons why we think there is a need for game-based learning in geology education. Beheshteh, if you go to the next one. So geology is a visual field and process-driven discipline that works well with hands-on learning. So these are the 6 items we summarized to talk about why do we think there is a need for GBL in geology education. Number 1 is that it bridges the knowledge gap. I teach in Georgia at University of North Georgia, as Beheshteh mentioned. In Georgia, students see geology last in 6th grade. And after that, from 6th grade to when they come to UNG, to university, they don't see really geology that much. It's not a required course, it's an elective. So many students enter our geology courses with little to no background in the subject. Teachers also who teach 6th grade, usually they are not geologists, so they often lack deep content expertise, making it challenging, especially when they try to convey complex concept effectively. Games proven to provide an interactive, low-pressure way to introduce complex concepts. Second is addressing the skills shortage. The geology workforce is aging. I see firsthand many geologists are retiring. Some passed away, unfortunately, and we have very few students pursuing careers in this field. Game-based learning can inspire the next generation of geoscientists and geologists by showcasing exciting career opportunities that might be out there. Number 3 is making learning more inclusive. Traditional method of teachings can be intimidating and inaccessible. Games try to cater to different learning styles. Either they are visual learner, tactile learner, auditory. Some students are multisensory learners. And this using games make geology more engaging for diverse student population. Fourth, which is also very important and we see every day, is leveraging students' familiarity with technology. Today's students are digital natives. They use games pretty much all the time, so they are very tech-savvy students. They used to interactive and engage experiences, and traditional method of teaching might be boring to them. This is some of the words the students tell me. So, lecture and textbook do not capture the dynamic nature of geology. Game based learning meets the students where they are. They are on screens, in simulations, and in virtual environments. So, that would be a good option for these students. Fifth is encouraging critical thinking and problem solving. Geology requires analytical skills to interpret data or predict outcomes, or we solve real world challenges. And games create these realistic problem solving scenarios that improves students the way they think, or how they approach problems, and enhances their problem solving and critical thinking. Last but not least is that it increases retention and engagement in classes. The studies shows that interactive learning improves retention rates. Game-based experiences make learning fun and memorable, and reduces dropout rates for geology courses. If we go to next slide, these are some of the statistics that we have. Game-based learning is gaining strong support among educators. 82% of teachers recognize its benefits, but many struggle to find the structured resources, which this is what we're going to touch on in a few minutes. The research also shows that GBL students outperform traditional learners in geology assessments. In fact, the students using Better Geo EDU, which is a type of Minecraft that Beheshteh mentioned, I'm going to talk about it in more detail. They saw a 40% improvement in mineral classification skills, which is one of the most important skills in studying geology. And in terms of engagement, GBL students show 60% more engagement than those in lecture-based classes. So the data shows integrating game-based learning into geology education enhances student performance, engagement, and understanding. Okay. All right. So one of the biggest challenges in implementing GBL in geology is choosing the right games. Not all games are designed with learning objectives in mind. So we must select games that align with geological concept and engage students effectively. There are three main types of game that we use in geology. Beheshteh talked about all three of them. I'm going to focus on sandbox games, and an example of it is Minecraft, that we're going to talk a little bit more about it. We also use simulation-based games that are physics-driven. I use this, one of them, especially virtual microscope. I use it in my upper level geology classes. And then also we have serious games that it's also used for upper level geology classes. Serious games, I use Seismic Explorer and NASA's Earth observation, and it helps a student having that spatial thinking and understanding about location, analyzing satellite data, using earthquake data, and so forth. So in next slide, I want to focus on an example of sandbox games. If you go to next slide, please. Thank you. So let me just talk about Minecraft for a second. Many of you might be familiar with Minecraft, but it's one of the most popular games in the world with 100 million plus players. My son is one of them, loves playing Minecraft. Players explore an open world made of blocks. Blocks in the world can be mined to gain different materials. Different materials can often be combined to craft new items. The materials used to craft in Minecraft are called raw material in real life, or we call it natural resources. And these are our building blocks that we depend on these natural resources. So they are very important, and we use them in production of almost everyday objects that we use. So Minecraft is a sandbox game. It's a type of sandbox game that's customized for geology learning. Again, it's used with middle school, high school students, and anyone who wants to have hands-on exploration of geology principle. Teachers are also faculty who are using Minecraft or Better Geo EDU, which is a version of Minecraft. They say that the students who are using it, they are performing better by 40% in mineral classification. And again, they are supporting the use of that in classroom. One thing is missing is it's lacking that structure behind of it, which is true. One of the biggest concern for teachers is that are they just playing or are they learning, and where is that learning happening? So if we go to next slide, I want to give one example of how Minecraft can be used for geology learning. So I think the top of the slide is not showing Beheshteh completely. Oh, next one. All right. Yeah, the one before, sorry. Okay, here. Yes. So here I put two different photos that is comparing the traditional method of teaching to a game-based method of teaching. And it's about finding and formation of a cave system. So finding a cave system is significant for a variety of fields, ranging from scientific research to also resource management. Caves offer excellent opportunity for scientific discovery by revealing Earth's geologic history, which is really important to us, including the formation of minerals, rock structures, if there is any fossil records. These environments are also crucial for ecological preservation, housing unique ecosystems that support rare and often endemic species, making them key to diversity conservation as well. So I want to talk about the right-hand side, which is the game-based method and using Minecraft. In Minecraft, this is through also my son. He told me that there's a specific plant that if I find that plant and if I dig under that, I'm going to find a cave. And then within cave, there are a lot of other fun things that can happen. So in Minecraft, players search for cave system. And what they do, they are using the tree that you can see in this slide, and it's a cherry blossom tree, and then sometimes it's a Zolia oak tree. And these are considered as a natural indicator. So again, students know it's a tree that looks like this, and if you dig on there, there is a cave. But they don't understand why this tree, and digging beneath this tree reveals an underground cave. So this is where the traditional method can come to help. Let me tell you a little bit about the science behind of it. Why do caves form under cherry blossom trees? Cherry blossom trees require calcium to grow, which is absorbed from the soil. If these trees are thriving in a specific area, it suggests that the underlying rock must contain a significant amount of calcite, which is a mineral, calcium carbonate, and is primarily found in limestone. Limestone is a sedimentary rock that is highly soluble in acidic water. Over time, rainwater absorbs carbon dioxide, CO2, from the atmosphere and the soil, forming a weak acid called carbonic acid, H2CO3. When this slightly acidic water seeps through the ground, and if the ground is made up of limestone, it dissolves the limestone and gradually create underground voids and tunnel, which eventually develops cave system. So the students play with the game. They know they dig under that, but they really don't know why. Why am I digging under that? So in now I want to talk about textbook version of it. So we talk about on the left hand side, we talk about caves, we talk about how they form, but it feels like it's provide the structural information, but without real world application, a student might struggle to grasp why cave forms. In the game based method, students can also dig under. They are aware of how deep they are going, what is the longitude, latitude, or coordinate, in what depth they are located. They can move around and really explore the whole setting. So it makes Minecraft based learning or geology through Minecraft based learning interactive, engaging, and memorable. but again needs some guidance to ensure students understand the underlying science. The best approach would be a hybrid model that integrates Minecraft gameplay with guided discussion, scientific explanation, and hands on activities that would maximize engagement and understanding. If you can go to next slide, please. So here is how GBL enhances geological learning. Again, a case study with the cave system that we just talked about. So there are 5 steps that we identified. Number one is problem encounter. So students are introduced to a geologic challenge within the game. In this case is cave system. Then they analyze initial clues, individual. It could be also including visual of rocks and plant samples, their characteristics. We give them some in-game data to establish a foundational understanding. The students analyze the plant types and also surface terrain to predict the location of underground cave system. They observe vegetation density, soil composition, moisture level as indicator of potential cave entrances. In step 2, we have virtual exploration. The students explore the terrain and navigate the environment of the game. They discover various rock types, plant types, underground landscapes, depth, coordinate, all of it. And then they document their findings and compare them with real world geological principles. Number 3 is interactive experimentation. Inside the virtual cave, the student explore and analyze rocks and minerals by conducting tests that may include like hardness tests, luster, streak, or also reaction to acids that we mentioned to determine their properties and identify key geological feature. Step 4 is knowledge application. Students apply their learning by first completing in-game quizzes that is related to the formation of caves. They engage in discussion, and this is done to compare their findings and refine their understanding. And then finally, conducting real-world field studies to find similar cave system based on surface indicator, and where possible, using their knowledge to identify rocks, minerals in a cave system, maybe even provide hand sample for them to do all these tests in real time and in their hands. So last part, which is also very important, is feedback and assessment. The student receive feedback through 3 different steps: automated in-game assessments that track their progress. They also get peer and instructor evaluation, of course. And then the last part, which I think is really important, is reflective exercises and reports that reinforce learning outcomes and also highlights any areas that might be needed for improvement. Okay, if we go to next slide. This one, it's not exactly game-based learning, but it's something that I do in my classes, and I thought we are talking about geology. Why not talk about my favorite thing to do? We are using microscopes, and this is an online conference, and I want to talk about how something so visual and so hands-on could be also taught online. The idea for me started from the pandemic. The picture that you see, the top right side is petrographic microscope. These are very expensive microscope, ranges between $8,000 to $10,000. Some schools might not be able to afford it to buy it, especially for the large number of students, and some might have students who are learning remotely. So this supports remote learning, making geology education accessible to students without even being in the classroom and from distance and from remote. So a little bit about what is this. Geologists use petrographic microscope to identify minerals based on their optical properties. They classify rocks, they analyze their texture, and study the formation of rocks. It's used in many, many fields, from engineering to environmental studies and sciences, geology, everything. They also aid in resource exploration, reconstructing geologic paths, where we get to examine mineral properties and understand their formation processes, their fabric, and so forth. So, a fundamental principle of this is optical mineralogy, and is that most minerals transmit light if we slice them thin enough. Even dark color that they might appear opaque in hand sample, they will look, you will be able to put it under microscope. This uses polarized light, and light passes through and you can study them. We create this thin section that is on the box on the bottom right hand side. The thickness, so we pretty much cut the rock to very thin slice and we mount it on a piece of glass. The thickness of the rock should be 0.03 millimeter to allow the light pass, and then we study the properties of mineral. The one that you see looks like panda. It's a photo micrograph of one of the rocks we collected from Alachi Nature Center right close to our campus. So this is a very exciting, cool way of engaging students in geology, but how to make it in a way that it's accessible to all the students. This is where we are using this virtual microscope setting, where on the left hand side photo you're seeing a specimen called cyanite. You can see how it looks like under microscope. You can rotate the object in 360 degrees and provide some fact sheets to students. So I've used that often in my classes, where letting students analyze samples, create geology challenges, give them mystery rocks, and then have them to earn points based on how accurately they identify rocks or how quickly they identify rocks, and then put them in leaderboard and let them compete. They also work in a team. Okay, next, please. All right, so I want to talk about integrating GBL into the geology curriculum effectively. Beheshteh explained this really well, but also I want to talk about it from geology point of view. So selecting the right game is only part of the equation, but to be truly effective, game-based learning must be aligned with curriculum objective. Many educators struggle with this step. A common concern is how to measure learning outcomes from games and how to ensure GBL supports standardized learning goals. Effective GBL integration requires careful planning, diverse assessment, as Beheshteh mentioned, so important, and a focus on enhancing, not replacing, traditional learning approaches is important. So, step one, define learning objective first and then choose the game. So most educators select the game first and then they try to force it into a curriculum. This is not the best approach. The best approach is start with well defined learning objectives and then pick the game that fits those objectives the best. So, for example, you might, for mineral formation and classification, it's better to use Minecraft or better Geo than using something like Seismic Simulator or other type of game-based learning that is around. Number two is blend GBL with traditional assessments. Challenge is that many students worry that educators worry that the students are just playing rather than learning. So we need to use traditional assessment. This include quizzes, reflection exercises alongside GBL. This ensures that students are learning all the learning objectives as well. Assessment includes pre-game, post-game quizzes, game-based reports. So it shows how students document findings from their gameplay. For example, write about mining processes in Minecraft. And then also student reflection. Ask students how game-based learning compared to traditional methods. What are your thoughts on that? Okay, it's still in the last one. I want to talk about the chart quickly. The blue bar chart illustrates the impact of game-based learning with post-game reflection, where students using GBL with post-game reflection retain 30% more knowledge than those who just played the game. And then the green bar talks about or shows or illustrates the impact of game-based learning with traditional methods on knowledge retention and engagement. A combination of them improves engagement by 60%. So, and the message is that GBL should not replace traditional method, yet instead be used as supplemental to enhance this learning. Next, please. Okay, so one of the biggest challenges we have in geology at university is recruitment and also retention. The challenges we have in recruitment, first of all, is perception of geology. I asked ChatGPT to give me a picture of a geologist. This is what it gave me, top right hand, an older gentleman with long beard in the field. So we noticed that we have a lack of diverse representation in the field. Like many STEM fields, geology has traditionally had lower levels of diversity, particularly in terms of gender and also minority representation. Um, Women might feel like this is not a field for them. A student with disability might think this is not for them. So geology seems like a track professional from a specific background and also in a specific region. There may be cultural or geographical barriers to attract a more diverse workforce. We also have limited awareness of geology careers among students as well. So makes it, and these are some examples of why what are the challenges in recruitment for geology. So GBL can help with that, and let's see how. One, GBL makes learning more fun and engaging, motivating students to explore geology and encouraging long-term interest for them. It also allows us to personalize learning experience for students, adapting to individual progress and interest, making geology learning more tailored and more relevant. Games, number two, games simulate geology scenarios, like the one we looked with the cave, for example, to give students hands-on experience in a risk-free environment, like digging and traveling to the Mariana Trench. Mariana Trench is the deepest part of the world's ocean, located in the Western Pacific Ocean. It reaches depths that are approximate to 36,000 feet. Makes it scary if you want to go in and then dig in, but game-based learning allow for that to happen, and you have a risk-free hands-on experience type of learning. Number three, encourages decision making, fostering curiosity, and also help learners to build the skills needed in real-world geology tasks. It gives you that type of like lifelong learning mindset and encourages you to continuously learn. Last part can be accessed via various platforms, makes it very flexible and widely available. It's also scalable. Based on our needs, we can expand it and make it as challenging or as deep as we want with our learning. It could also be easily expanded to other field of STEM, biology, chemistry, physics. It could be easily expandable to them. It also promotes collaboration and teamwork. We have multiplayer or team-based game that it helps with communication, teamwork, which is essential for skills in geology field. Okay, get to the conclusion. So imagine a learning experience that truly enhances engagement, making geology education not just informative, but also fun and motivating. That would be GBL. It leverages the students. We are leveraging students with interactive simulation and dynamic content, and students remain actively involved and they want to explore more and more. With the second one, personalized learning, through that, the platform adapts to individual progress and interest, as I mentioned earlier, ensure that each learner moves at their own pace and they focus on areas that sparks their curiosity the most, offers hands-on experiences, again, in a risk-free environment, and it goes beyond just theory. It builds real-world skills, encourage practical problem solving for students. And as learners progress, the system encourages growth and then fosters continuous learning and improvement for students. Accessibility, both Beheshteh and I touched on, it's very important, it's key in any STEM field, and geology definitely included. And it helps us with team building, teamwork, and collaboration, which in general strengthens the whole communication and problem solving skills that's crucial for geology. I think this is the last slide for us. Thank you, everyone, for being here, and we'll take any questions that you might have.
If anyone has any question, please feel free to write in the chat. Yeah, thank you. Thank you, Maka. Do you have any question, anything, any point, Maka? Please feel free to share. All right. Thank you for attending our session. We hope these insights on integrating challenges, storytelling, real-time feedback and exploration, and also collaboration into geology education were valuable. And GBL is really good, great, teaching strategy as a supplementary, as Katayoun mentioned, is very important to take it as a supplementary way of teaching to enhance the students' learning experiences. Anyway, your experience, yeah. So Maka mentions DPL and educational game in a general can make learning active and experiential instead of passive. Definitely, you're right. Making using games in a very well designed components is very important. As I mentioned, it's very important to consider the ways that we can design the game in a very effective way, so that students can enjoy learning experiences and also be more engaged, enhance their learning outcomes, and also feel good in the class, because they will have fun when they are learning. Anyway, if there is no question, um, again, I want to um, thank you again for joining us, and have a great rest of the day.
Thank you, everyone. Yeah. Waka is asking a great question. That's the biggest challenge. Many, again, they think it's it's just a game, and they don't want the students to spend time playing a game. I think once they see, we have a project coming up, hopefully with Beheshteh, we are designing a game for university level. We are using Minecraft and then expanding it to the way that it has those structural knowledge in the background. We are creating assessment quizzes, all of that, and then check in during the game. Hopefully, one of our plans are invite teachers to come and then we demo for them, and then we need to get the buy-in from other professors and then show them that firsthand this is actually working. The survey data we're going to collect, hopefully that helps to convince some of these educators as well. But yeah, it's a big challenge.